Welcome to the Explainer. Have you ever looked at a smart device and just wondered, how does it actually work? Well, today we're going to break that down. We're going to see exactly how you can take a simple idea and bring it to life using some tools that are way more powerful and easier to use than you might think.
You know, it almost always starts with a simple question, just like this one. You're looking at some everyday object and that little thought pops into your head. What if this could be smarter? That's the spark we're going to follow today, the one that takes you from just being curious to actually creating something.
So let's just run with this idea. A houseplant that can literally tell you when it needs water. It's simple, it's practical, and it's the perfect example for us to follow, all the way from that what-if moment to a real working prototype. You're about to see just how achievable this really is.
Okay, to make our plant smart, it's going to need a brain. And for our project, that brain is going to be this tiny but really powerful little computer called an Arduino.
Now, before we really dive into the Arduino itself, it's important to get what it is. It's a type of microcontroller. So forget about your complicated desktop computer for a second. Think of this as a small, super-focused computer whose entire job is to just run one specific program over and over again. Like, say, checking if soil is wet or dry. That's its whole world.
So why start with Arduino? I mean, there are other options out there. Well, it's pretty much the perfect entry point. The hardware designs and the software are all open source, which means they're free for anyone to use. It's specifically designed for beginners, so you absolutely do not need an engineering degree to get started. Plus, the boards themselves are really cheap, and maybe the best part, if you ever get stuck, there is a massive global community online ready to help you figure it out.
All right, we've got our brain. But a brain is kind of useless without instructions, right? We need to tell it what to do, and we do that by speaking its language, which is code.
The place where we write all these instructions is called the Arduino IDE. That stands for Integrated Development Environment. But really, just think of it as a simple, free app for your computer. It's the command center where you'll type out your code and then, with just one click, send it straight to the Arduino board.
And this workflow here really shows you just how simple the whole process is. You write some code in that IDE, you connect the board to your computer with a totally normal USB cable, and you just hit the upload button. Honestly, the best part is that last step, seeing your project physically react to your code in the real world. It is an incredibly cool moment.
So our little brain can now follow instructions. Awesome. But how does it actually interact with the physical world? Well, we need to give it senses to perceive its surroundings and a way to act on what it senses.
You know, the best way to think about this is like it's a living creature. It needs senses to gather information. Those are our inputs. And it needs muscles to perform actions. And those are our outputs. Simple as that.
This table breaks it down perfectly for our plant project. You can see it right there in the project example column. Our sensor, the input, is a soil moisture sensor. It just gathers info. And our actuator, the output, is a simple little LED light. It performs the action, which is blinking when the soil is dry. Sense and act.
So how do the brain, senses, and muscles all talk to each other? Well, they use something called serial communication. Don't worry, it sounds technical, but just think of it as a tiny digital nervous system. Using a simple protocol called UART, the brain is constantly listening for data from the sensor and then sending commands out to the actuator. It's that invisible link that makes the whole system actually work together.
Okay, our plant project is pretty smart now. It knows when it's thirsty, and it can blink a light to let us know. But what if we're not in the same room? How does it get our attention? Well, it needs a voice.
And this is where we really enter the whole Internet of Things idea. As you can see, we have two main options. For long-range communication, we can add a Wi-Fi module. This connects our little project right to the internet so it can send you a notification anywhere in the world. For short-range stuff, a Bluetooth module can talk directly to your phone when you're nearby, which is perfect for building a custom little control app.
And there you have it. This is basically the recipe for almost any IoT project you can think of. You connect the brain, you add the senses, you program the language, and you give it a voice. If you can master these 4 steps, you can build pretty much anything.
So, we started this whole journey with just a thirsty plant. But as you can see, these same components, the brain, the senses, the code, the voice, they can be reconfigured in endless ways. You have the fundamental building blocks now. The only real question left is, what are you going to create?